So we were learning some aspects related to how to create histogram and bar diagram and SPSS software. So creating a histogram is used to visualize the distribution of a single continuous variable. So for this example, let's say you want to create a histogram for a variable called scores. So step 1, open your data file, launch SPSS and open the dataset that contains your scores variable. Access the chart builder, go to the graphs menu at the top. Select chart builder from the drop down menu, choose histogram. In the chart builder dialog box on the left side, you will see different types of charts. Select histogram under the gallery of charts. Drag and drop histogram into the main chart area on the right, then define the variable in the elements area on the right. In the variables box, select and drag the variable scores into the x-axis box. Then customize the histogram. You can customize the appearance of histogram by clicking on the element properties button on the chart builder dialog box. Here you can adjust settings like the number of bins, axis labels and other visual aspects of the histogram. Then create the histogram. Click the OK button in the chart builder dialog box to generate the histogram. Then creating a bar chart. A bar chart is used to visualize categorical data or the distribution of a single categorical variable. For this example, let's say you want to create a bar chart to show the distribution of the categorical variable called categories. Then open your data file, launch SPSS and open the dataset that contains your categories variable. Then access the chart builder. Go to the graphs menu at the top. Select chart builder from the drop down menu. Choose bar chart. In the chart builder dialog box on the left side, you will see different types of charts. Select bar under the gallery of charts. Then drag and drop simple bar into the main chart area on the right. Define the variables. In the elements area on the right, in the variables box, select and drag the variable categories into the category axis box. So optionally, you can drag another variable into the values box if you want to create a grouped bar chart. Then customize the bar chart. You can customize the appearance of the bar chart by clicking on the element properties button in the chart builder dialog box. Here you can adjust settings like axis labels, grouping options and other visual aspects of the bar chart. Then create the bar chart. Click the OK button in the chart builder dialog box to generate the bar chart. These steps should help you to create histograms and bar charts and SPSS to visualize your data efficiently. Remember to customize the appearance and labels as needed to suit your specific data and analysis goals. Then next topic, how do we know which graphical depiction will be best for a set of data in SPSS? So selecting the most appropriate graphical depiction, chart or graph for your data in SPSS or any other data analysis tool depends on several factors including the nature of your data and your research objectives. Here are some guidelines to help you choose the right graphical representation. Data type, continuous data. For continuous data, age, income, you might consider histograms, box plots or line charts. For time series data, then categorical data. So for continuous data, you might consider histograms, box plots or line charts. For time series data, then categorical data. For categorical data, gender, region, bar charts, pie charts and stacked bar charts can be effective. So number of variables, single variable. If you want to visualize the distribution or summary of a single variable, consider histograms, box plots, bar charts or pie charts. Then multiple variables. When comparing two or more variables or groups, options include grouped bar charts, stacked bar charts, line charts and scatter plots. And data distribution, symmetric data. Histograms and box plots are useful for displaying the distribution of symmetric data. Skewed data. If the data distribution is skewed, you may consider transforming it using a specialized chart like violin plot or quartile plots. And comparison and relationship, to compare data across categories or groups, bar charts, stacked bar charts, grouped bar charts, and radar charts can be effective. So to visualize relationships between two continuous variables, scatter plots and line charts for time series are common choices. Trends and time series. For time series data, or when you want to visualize trends over time, line charts and area charts are often used. Then proportions and percentages. When dealing with proportions or percentages, consider pie charts, stacked bar charts and tree maps. Frequency and counts. When your data consists of counts or frequencies, bar charts including grouped and stacked variations are commonly used. So then data size is also an important factor related to this. For small data sets, it's often possible to use detailed charts like scatter plots or small multiples. For large data sets, consider summary variations like histograms, box plots, or aggregated bar charts. Consider your audience familiarity with the different chart types. Choose charts that are easy for your audience to interpret. Then research objectives. Think about the specific research questions or insights you want to convey. Different chart types may be more effective for different objectives. Then testing assumptions. Some charts, like normal probability plots, are used to test assumptions about the distribution of data. Then trial and error. Don't be afraid to experiment with the different chart types. Create multiple charts and choose the one that best represents your data and communicates your findings. So remember that effective data visualization is not just about creating pretty charts. It's about conveying information accurately and helping your audience understand the data. Be prepared to iterate and refine your visualizations to find the best representation for your specific dataset and research goals. In psychology related projects, the choice of the best graphical depiction depends on the specific nature of your data and the research questions you aim to address. For example, continuous data, test scores, reaction times, histograms to visualize the distribution of scores. Then box plots to display summary statistics and identify outliers. Then line charts for time series data such as tracking changes and responses over multiple measurements. Then categorical data, for example, gender, marital status, etc. Then bar charts to show the frequency or percentage of each category. Once again, I'm going to read this. Histograms were used to represent continuous data. Then box plots to find outliers and summary statistics. Line charts for time series data. For example, gender, marital status, we will be presenting bar charts to show the frequency or percentage of each category. Pie charts for displaying proportions of categories in a whole. Then stacked bar charts, useful when you want to compare categories across subgroups. Then comparing groups or conditions, for example, experimental versus control. So grouped bar charts for comparing means or frequencies between different groups or conditions. Then line charts, if you have time series data for different conditions, you can use line charts to show how they change over time. Then box plots to compare distributions between groups including medians, quartiles and outliers. In correlation or relationship between two variables, we will be representing scatter plots. To visualize the relationship between two continuous variables, useful for examining corrections. Then regression lines. If you are conducting regression analysis, including a regression line on a scatter plot can illustrate the relationship. Then experimental design, pre-test versus post-test. Paired bar charts for comparing data before and after an intervention or treatment. Then line charts to show trends over time for each group of conditions. Survey responses, bar charts to display the distribution of responses for each item. Then grouped bar charts when you want to compare responses between different groups or conditions. Then qualitative data, open-ended responses, qualitative interviews. We will be forming word clouds for visually representing the frequency of words or phrases in qualitative data. Then thematic maps to display themes or patterns in qualitative data. So neuroimaging data, brain scans, brain maps, specialized visualization techniques like brain activation maps and connectivity diagrams for neuroimaging data. Ultimately, the choice of the best graphical depiction for your psychology related project depends on your research questions, the type of data you have, and the story you want to convey. It's important to select visualizations that effectively communicate your findings and insights to your audience, whether it's other researchers, clinicians, or the general public. So, how to get Pearson coefficient in SPSS? To calculate Pearson's correlation coefficient, often denoted as small letter r, in SPSS, follow the steps by each step. So open your data file, launch SPSS and open the data set that contains the two continuous variables for which you want to calculate the Pearson coefficient. So access the correlation analysis, go to the analyze menu at the top. Select correlate from the drop down menu, choose bivariate from the sub menu. This will open the bivariate correlations dialog box. Select variables in the bivariate correlations dialog box. On the left side, you will see a list of available variables. Select the two continuous variables you want to correlate, for example, variable 1 and variable 2. So use the arrow buttons to move this variable into the variable box on the right. Then options, it's optional. If you want additional statistics along with the correlation coefficient, click the statistics button in the bivariate correlations dialog box. In the statistics dialog box, you can select various options including means and standard deviations to obtain descriptive statistics for each variable. Then histograms and normality tests to check for normality. Confidence intervals to estimate the confidence interval for the correlation coefficient. Click continue after selecting your desired options. Correlation coefficient output. Click the OK button in the bivariate correlations dialog box to run the analysis. SPSS will generate output that includes the correlational matrix, which includes Pearson's correlation coefficient between the two selected variables. Then interpret the results. So locate the correlation coefficient R in the correlation matrix table. It will indicate the strength and direction of the linear relationship between the two variables. The range of possible values for Pearson's correlation coefficient is -1 to 1. If R is close to 1, it indicates a strong positive linear relationship. If R is close to -1, it indicates a strong negative linear relationship. If R is close to 0, it suggests a weak or no linear relationship. So additionally, you may see the associated p-value, which indicates the statistical significance of a correlation. A small p-value, typically less than 0.05, suggests a significant correlation. So that's how you calculate Pearson's correlation coefficient in SPSS. So remember that correlation does not simply imply causation, and it's important to interpret the results in the context of your research question and data. Then once again, we are going to learn about how to perform chi-square test in detail. So first, open your data file, launch SPSS and open the dataset that contains the data you want to analyze with the chi-square test. Access the crosstabs procedure. Go to the Analyze menu at the top. Select Descriptive Statistics from the drop-down menu. Choose crosstabs from the sub-menu. This will open the crosstabs dialog box. Then define rows and columns in the crosstabs dialog box. On the left side, you will see a list of available variables. Select the variable you want to use as your rows, usually the categorical variable you want to analyze, and move it into the rows box on the right using the arrow button. Similarly, select the variable you want to use as your columns, another categorical variable, and move it into columns box on the right. And statistics, if you want to include additional statistics in the output like chi-square, phi, and Cramer's V, click the statistics button in the crosstabs dialog box. In the crosstabs statistics dialog box, select the statistics you want to include and then click continue. Then cells, to include expected counts or percentages in the output, click the cells button in the crosstabs dialog box. In the crosstab cells dialog box, select the desired options like observed, expected, row, column, and then click continue. And format, if you want to format the appearance of the output table, click the format button in the crosstabs dialog box. And in the crosstabs format dialog box, you can customize the table layout, fonts, and other formatting options. Then click continue when you are done. Run the analysis. So click the OK button in the crosstabs dialog box to perform the chi-square test. Then interpret the results. SPSS will generate output that includes the cross tabulation table, chi-square statistic, degrees of freedom, and associated p-value. Then examine the chi-square test table in the output to find the chi-square statistic and its associated p-value. A small p-value, typically less than 0.05, suggests a significant association between the two categorical variables. Then report the findings. Report the results of your chi-square test, including the chi-square statistic, degrees of freedom, and p-value. Describe the nature and significance of the association between the two variables. And this is how we perform this. It's used to assess the association between two categorical variables and determine if this association is statistically significant. So what is one-tailed and two-tailed test? A one-tailed test and a two-tailed test are two different approaches to hypothesis testing in statistics. So one-tailed test, also known as directional test, which we will be learning tomorrow. So thank you for listening.